In this video, we're going to go over how to download QGIS and Natural Earth data to start getting us set up and ready to start working with QGIS. So the first thing we're going to do is going to go to QGIS Download and select Download QGIS. For the sake of simplicity, we'll go with the QGIS standalone installer version. Use whichever the current one is. For us right now, it'll be 3.20. You'll see your download, and we'll let that run. While QGIS downloads, we can actually come here. I'll have a new tab open and type in Natural Earth. When you see Natural Earth come up, go to Downloads. And we're going to go with the large-scale data, as it will be larger, but it'll provide more information. You'll see that we have a cultural, physical, and a raster. Cultural will be things such as information on cities, roads, counties, political layers. Physical is just what it sounds like. It's your oceans, your lakes, your rivers. And rasters tend to be more images or digital terrain elevation data. We'll start off with the cultural and download all 10-meter cultural themes. And that will download everything below here. You can see the download starting over here. As that downloads, we'll back it up and go to Physical, where we will do the same thing. Download all 10-meter physical themes. Back it up one more time. And now we'll do raster. The raster provides quite a few more options. And a lot of these will help to make better looking maps, but they will also offer you opportunities to do more advanced features as well, such as viewshed analysis. And of these, I will start off with gray earth. I will usually download it with everything included. You'll see some of these just have the shaded relief and hypsography, which is mostly just for your surface. Over here, you'll start getting flat water, and then you'll start getting ocean bottom and so forth, and some of your river drainages and such. And I'll go for the large size. Now, this one downloads fairly quickly. I will also do a shaded relief, and that's just for when I want to create a very quick map with limited shading in the background for terrain elevation. 80-something odd megs. This one is 42, so it will load a little bit lighter, especially on computers that may have some performance limitations. Okay, we are pretty much done with all of these downloads. Let's go ahead and start this. So we'll just click Next. You could read through this, but like any other EULA, at the end of the day, you could just accept, hit Next. I'm going to change this just because of my setup. You could accept it the way it is. That is absolutely fine. Okay, now just click Finish, and you should be done. I've created a desktop icon for QGIS. As you can see here, and double-clicking it will open this up for us. So this is what will first come up once everything is done loading. It'll take you to this landing screen here. What I'm going to do upon first opening is go to Options, and everything else, for the most part, can remain the same. The two things that I will change is going to be the reference system for the coordinates. And while WGS 84 is fine, I'm going to go with, and I'll show you how to get to that. If you just type Google in here, you'll see Google Mercator's global map. And I'll select the same from here. You may have to click on this and do the same search. The reason being is that the Google Maps Global Mercator is a metric-based map, which will become an issue with some of the things we will do later that require a metric-based map to be able to function. Otherwise, we get into complexities of having to do conversions, and it's just easier to start off with a metric system. So beyond this, the other part that we'll do is if you come down here to rendering, I'm going to max it out at 4 cores. You could do more or less depending on your computer's capabilities. And under Canvas and Legend, I'm going to select a blue color. So what I will do for the background color, I'll click here, and then over here, I will input this hexadecimal code that is B9E6EC. And then that way your default background color is going to be an oceanic color. That way you don't have to try to manually put in watercolors or water body layers. It could help reduce the weight of your map if you already have those carved out in some of your graphics, and more on that later as we go through this process. Okay, click OK, and now you should be ready to start yourself a new project. So we will go ahead and click on New, and we have a clear blue map, and we'll pick it up from here on the next video. So now that we have downloaded the natural earth files, one of the things I think is important to talk about is file structures. And before you start creating maps and unpacking a lot of the data that we've downloaded, it is in your best interest to figure out how do you want to structure your GIS folders to make it easier to find data later on and to keep things organized as you work. Initially, you'll start off with a few files, but pretty soon you're going to have a jumble of information. So here I have 3 different concepts, and to be certain, this is not the only way to really divide things up. One is by data type, and you'll have your overall GIS folder, and within there you could have vectors and rasters. Vectors are formed by points and or line segments, and they're mostly used to identify features or locations using an XY coordinate, basically Cartesian plane type coordinates in GIS products. They could typically be either point, which is used to identify specific locations, a populated place, mountain or hill peak, addresses. Lines, which are used to depict features that are typically linear, like roads, railroads, streams, contour lines, borders, or polygons used to define whole areas, countries, lakes, oceans, a parking lot. And then you have rasters. And raster data is basically like a picture. It's formed by a series of cells or pixels in a grid pattern, creating an image with each cell or pixel having its own numeric value or descriptive/class. And these can either be discrete, to where each cell or pixel has discrete independent value. So think of it like a terrain type where you can have water right next to a tundra. So the 2 pixels don't have to be related. Or continuous, where the data changes gradually between pixels and cells. So think of elevation, where usually elevations next to each other have a distinct relationship to each other. So most imagery and elevation data will be raster. So under vector, you can have political, demographic, economic information. And under rasters, you'll usually have elevation, imagery, and you'll have other rasters that we'll build as we go through that may fall under its own category, but it would still be under raster, and we could call that processed information. The other version here is a data source base. So for example, we downloaded information from Natural View, and that could be source 1 over here. That could be Natural View, and then we'll put all the vectors in here and all the rasters, and we could further divide down from here. And then source 2 could be a USGS service, or it could be NASA information, or any of a number of sites. And it would just keep flowing through this same type of structure. And I put source 1, source 2. You'd have as many source folders as you needed. Just keep in mind, if you end up having quite a few source folders, it can get really messy, and you should question whether that's the best structure. So this is more useful if you're just going to work with a finite number of sources, and the source is your primary concern, your highest point of interest. And these folders in orange should really reflect what is the most important aspect to the work you plan on doing with Qgis. Going on to functional, once again, this is almost an inverse of your data type where you would put down, in my case, political, demographic, economic, and then within these you would have your vectors and your rasters. Now, this will bring me to one more point of discussion, and that is, as we get into this, we'll be moving shapefiles to help organize things. Shapefiles actually consist of multiple files. So at the very least, they'll have 3 files. A lot of them will have more. But if you plan to move a shapefile, you have to move all of the files or you will essentially break your shapefile. They will typically have the same name but a different extension. So for example, if you had a shapefile named ABC, you'll see at the very least in abc.shp, in abc.shx, and an abc.dbf. And these files in order, your SHP is your main file. It's a direct access record file with varying lengths, and basically it describes a shape with a list of vertices. You'll have a .shx, which is the index file, and the .dbf, which is your D-based table file that contains the feature attributes with 1 record per feature. Some of the other ones you may see are .prj for projections, .xml, and .cpg, which is to identify a code page for character sets. There's quite a few more. I'll put a link at the bottom of this video so you can see. It's from the Library of Congress, just showing some of the different formats. Once you have your folder done, we will go through some of the unpacking. We start working with these files. These are the files I downloaded. And under GIS, I created a raster and a vector. I'm going to start with the raster, and you'll see I made a regional world folder. We'll expand on this as we need to later on. So going in here, I have digital terrain elevation data, which most closely matches what these two are. These were the shaded relief and the gray rasters that we downloaded. We will bring those 2 zip files here, and we will extract all of them into the appropriate name folder, but it is in our best interest to make sure that we name them properly. I like to avoid using spaces in file names just because some programs are a little bit touchy about that. Okay. That was a little unnecessary. I knew this was going to happen, that it would create a folder with the files I need. I will pull those files out and then delete that folder. And then we'll repeat again for the grayscale. Once again, we will copy all of these or cut them, paste them here, and delete this folder. Okay, now that we're done with that, we can go back out to our vector folder. And let's go back to our downloads. And we will take these physical and cultural and drop them in here. This here is a separate file I downloaded. So let's go ahead, extract these one at a time here. This one here, we'll just extract like that. And lather, rinse, repeat while that one extracts. Once that's done, we go ahead and delete these. And once you come in here, you'll see that you have a large collection of different files. All of these have a README that'll give you a description of what all of these files are. For now, what you'd want to do is to start creating folders where you can extract some of these that we will frequently use so you do not have to continuously fish for them. So what you will see is up here, I've created folders for the cultural section with some of the things that we'll use on a regular basis, some of the files. And what we're going to do is copy and paste from in here to put them within these files. That way we don't have to continuously fish for them. I'll post at the bottom of this video the folder names that I've used, starting off with the countries. I'll do a search, and we want to grab all of these files. It goes back to our previous discussion. You need all of them, and you can see this has DBFs, PRJs, SHPs, the whole 9 yard. But, okay, so that's the first one. These are the boundaries, the country boundaries. Populated places. And for the populated places, you'll have a couple of different options on them. You'll see that some of these say simple, and some of them do not. The simple ones are a little bit of a lighter load. They are devoid of some information, and it's going to be up to you. I am going to pull the full versions for now, and I'm not. So you'll see I left the ones that have the word simple next to them, and I also did not pull in the LandScan README. It's just discussing how they pulled some of this information here from that. So we'll come to populated places, paste these, and last but not least, for the states, you'll see they have quite a few of these. I am looking for just the regular ones without the lakes, lines, or anything else. Now, within states, I am going to make one more with lakes folder, and we will go back to here and do search for lakes. We can do the same thing. The countries already have them. There's a good reason behind that. But we're pretty much done with the cultural. We'll take and repeat the same process here for the physical features. The rivers do not get the scale or rank ones, just get the regular version. Here, let's add a dot at the end of this. It should help sort it out a little bit better. And the lakes, once again, just the ones here. There's a whole bunch of other regional ones, but we don't need that. And with that, we should be good for now.